This hearing is now back in session. At this time, we will hear testimony from Mr. Dave Dyer, University of Washington Applied Physics Lab. Okay. Mr. Dyer?
Yes.
The recorder will now administer the oath.
Okay.
Good morning, sir. Could you please stand and raise your right hand for me? A false statement given to an agency of the United States is punishable by fine and/or imprisonment under 18 USC 1001. Knowing this, do you solemnly swear that the testimony that you're about to provide will be the truth, the whole truth, and nothing but the truth? So help you God.
Yes.
Thank you. You may be seated.
Thank you.
Mr. Dyer, thank you for being here today.
Yes.
Lieutenant Commander Williams is going to start with your question answer.
Okay.
Good morning, Mr. Dyer.
Hi.
Thank you for being with us here this morning. As we ask you questions, we will take breaks. If you need a break, please let us know.
Okay.
All of my questions are related to your background and your experience with OceanGate.
Okay.
Before we begin, I will ask you to please refrain from using acronyms. If you should use an acronym, I will stop you and ask you to explain what that acronym means. Can you please explain your background and history before you became involved with OceanGate?
Yes, I have a degree in ocean engineering from Cal State University, Long Beach. Right after graduation, I started working for Rockwell International in their Marine Autonomy Group. Most of that was working on advanced submarine warfare projects. That involved submarine communications, it involved boundary layer control, and it involved sonobuoy type technology. From there, I moved over to Hughes Aircraft, working in the dynamics group, so we would do the analysis for shuttle and Ariane and Titan launches to determine how satellites would survive or have issues with the launch. During that time, I also did some work with GM. GM purchased Hughes Aircraft shortly after I was there. I did a little bit of work on some of their solar-powered cars, specifically looking at their carbon fiber structures for solar panels. At that time, after that, then I moved up to Washington, working for Hughes Aircraft at a Boeing facility. Was working on satellite integration, so that was looking at the entire satellite systems, integrating it together, doing the testing on it, and getting it ready for launch. And then I participated in the launch support for those satellites. Then I moved over to Boeing, started working for Boeing in the Sea Launch program, worked there for a period of time, and then moved into their Advanced Composites Research Group, where we were really given free rein to work on whatever projects we felt were applicable to Boeing and what they were doing. Then moved over to Precor, doing exercise equipment. Started off in the consumer part of that, working on the actual products, and then I was put in charge of the research and development group. And we were responsible for kinematics, so how does the equipment interact with the human body, and the exercise physiology portion of that, making sure that people were able to use the equipment to the best of their advantage on there. Then moved over to Applied Physics Lab, was brought in specifically to work with the associate director on bringing new programs into the lab, whether they were ONR, Office of Naval Research, or DARPA, which is Defense Advanced Research Programs Administration, I think is what that one is. Working on programs on there, so those were things where we would do conceptual work, looking at underwater vehicles, crawlers, things like that, that would be applicable to what Office of Naval Research and DARPA needed to do. That was when we, at that point in time, about halfway through that, Mr. Miyamoto started working on developing what he called the collaboratory, and that was meant to be an interface between industry and the university. And the goal of it was to give industry access to research that was going on in the universities that they normally wouldn't have access to. And then we would also work to help them find partners that could help them through technology. So most of the companies, when they start off in these high-tech things, they don't necessarily have all the expertise on their company. So we would help them find people that could come in and kind of bridge that gap for them. And that's really how we got started with OceanGate, is we used OceanGate submersibles, the existing ones that they had. I believe it was SUDS at the time is the one that he used. We used that for obstacle avoidance program. that we were working on for Office of Naval Research.
Who initiated the conversation between OceanGate and the University of Washington Applied Physics Lab?
It's hard to tell who initiated that. Bob and Stockton were talking together. Bob sought Stockton out to use their submersibles. And when Stockton started talking about what his vision for the company was, Bob offered to have APL come on and help him get going on there. At the time, OceanGate didn't have any engineering capability. So the idea was that we would come in and provide that engineering capability while they built up their engineering staff. And at that point in time, we could then step back and just come in occasionally or be advisors to them from that point on. So I believe it was kind of a lunchtime discussion between Mr. Miyamoto and Stockton.
And how did the relationship start out?
We started working with that project on them, the obstacle avoidance program. And then once it was determined that we were going to help them out, Mr. Miyamoto and Stockton put together a contract, and that contract was a very wide open contract. It was meant to be something that allowed a lot of flexibility in there. It allowed us to come in and go in and out on these programs as needed by OceanGate.
And what year was that?
That was about 2012, 2013.
And how far along was the design of Cyclops 2, which later became Titan, when you started working with OceanGate?
Cyclops, we started working with Cyclops 1. Once Cyclops 1 was working, we started working on Cyclops 2. So when we started that contract with them, Cyclops 2 was on the books. It was just something that was to be worked, but we had not started off on Cyclops 2 right off the bat.
And are you aware of how far along OceanGate had gotten into the design process for Cyclops 2 at the time?
I think it was all conceptual stuff from Stockton. I don't think they had really any design work at that point.
Were you involved in any conversations for the carbon fiber hull, where the hull was originally designed from 10 inches, then to 7 inches, and then it was finally 5 inches thick?
We were involved in some of those discussions. I believe that started off with Boeing, working with Boeing on that. I don't ever remember it being up to 10 inches. I do remember it being closer to 5, somewhere between 5 to 7 inches under that part. Then Boeing worked that for a while, and then it was shifted over to Spencer Composites that continued working on that.
So the University of Washington Applied Physics Lab didn't have any maybe stock in changing it from 7 inches to 5 inches?
No, we were not the carbon fiber experts. We were relying on the other ones, and that was part of our deal with Stockton of, if we don't have that expertise on there, we will help them find someone. We pointed them to Boeing because of our work that we had done with Boeing and some of the composites. And then Stockton later shifted that work to Spencer Composites.
What was your experience working with the operations department of OceanGate?
I worked fairly closely with them. I'm a huge fan of when you're developing something, you work with the people who are going to be the end users of it. So I worked closely with the operations group when we were doing the Cyclops 1 vehicle. And then early in the process of Cyclops 2, we were still continuing that relationship with them, working with them. And I would describe it as a very good relationship.
Lieutenant Steele, could you please bring up Exhibit 16, the University of Washington research proposal on page 2? Mr. Dyer, are you familiar with this document?
Yes.
And what was your understanding of the intent of this research proposal?
The intent was to provide engineering expertise to OceanGate as they work through the design of Cyclops 1 and then moving that into Cyclops 2.
Lieutenant Steele, could you please scroll down to page 4? I'd like to draw your attention, can you scroll up just a little bit? Up. Thank you. I'd like to draw your attention to the number 6 and number 7 of the technical approach outlined in your proposal.
Yes.
Can you explain to me the importance of assessing performance and reevaluation?
That's huge. That's the key to success. You've got to be able to take your designs, prove the design through test and evaluation, and you've got to be able to understand what that test data gives you and understand what the impact is on the design. So it's crucial.
Now drawing your attention to the second paragraph on the same page. I think you might need to scroll down a little bit. The proposal states trade-off studies will be provided to look at the basic design and fabrication of the pressure hull, especially the mating of the pressure hull to the exterior viewing ports and necessary through-hull connections. Can you explain to me what is meant by trade studies?
It's looking at possible solutions. So when we start off, you'd look at it, you develop concepts of this is what we think can happen on there. And as you go through the design on that, you start refining it, start doing analysis on that, and based on that analysis, you refine your design even further. At some point in time, you can take a step back and you can look at, okay, we're heading down this path. This is the implication, or this is the impact of this design. Are there other alternatives that might be better for this? Are there trade-offs that we can look at that might benefit the program?
And were these trade studies to be completed by UW-APL, or was it to be done externally, or could it be a combination of the two?
It could be a combination of the two.
How much involvement did the University of Washington APL have with the design of the carbon fiber pressure hull?
We were involved in the initial concept on that. We were providing concepts, and the first group that we worked with was Boeing. And we relied on Boeing to provide their expertise for their carbon fiber. We were providing expertise for deep ocean work and what was required for that. So we were helping them understand what the loads would be and what those design requirements would be. But we were really dependent upon them to actually define and design the carbon fiber structure. We were involved in doing the interface between the dome and the carbon fiber structure. But again, that was in collaboration with Boeing. So as we would present ideas and concepts, they would take a look at it and give their feedback. And then we would take their feedback and either incorporate it or convince them that what we were looking at was adequate.
And Lieutenant Steele, could you please bring back up that exhibit and go to page 5, paragraph 2? At the end of paragraph 2, it states, testing of the pressure hull will initially be conducted without humans and then turned over to OceanGate for final safety approval and testing. Was the initial thought that UW-APL would test the full-scale pressure hull?
No, we didn't have the capability of doing that. If when they got to that point, if they needed our expertise or help in that, we were going to provide that expertise or that help in it. But we don't have the capacity to do the full scale.
At the time, did OceanGate agree to the initial testing that it should be unmanned?
Yes.
And what is the importance of conducting unmanned testing?
Especially something where you're pushing the envelope on technology. You're making changes that are not something that the industry necessarily is used to. You want to test that without human life involvement in that. You want to make that as safe as possible. So it'd be crucial to do those initial tests without a human involved.
Would you consider one unmanned dive to be sufficient before putting people on board?
No, I wouldn't.
In your experience, do you have an approximate amount of unmanned dives that would be appropriate?
I don't know if I could give you a number. It would be something where we would look at the data after each test and see what the data is doing, see if it's repeatable. Are you seeing change from dive to dive? And that would be the key for me for making a decision on how many you would need to do.
Lieutenant Steele, could you bring up Exhibit CG018? It's the email correspondence between the University of Washington and OceanGate, specifically page 15. Could you scroll down a little? Thank you. In that correspondence, the University of Washington states, to complete items 1 and 2, I will need some level of test data to ensure my FEA, finite element analysis, model adequately represents the carbon fiber hull stiffness and interface boundary conditions. Mr. Dyer, in your experience, what type of test data would be required?
Sorry, stand by for a moment.
You said that this is an email from APL. I just want to confirm, does Mr. Dyer recall this email? Is this his email? Because no names appear.
Yes, thank
on
you.
what he's looking at.
I think it's the first question. Mr. Dyer, do you recognize this email?
I recognize the content. I don't know if I could say I recognize word for word, but I do recognize the content, yes.
And are you familiar who it was to and who it was from?
I'm not. That looks like something that might be for me, but I don't know that for sure.
Okay. Thank you, sir. Lieutenant Commander Williams, do you know who this email is to and from?
Sir, my questions are actually relatively general, so I don't think it would matter who it was from.
In that case, do we need, I mean, what are we referring to on the document? We can ask him generally.
Okay. Yeah, let's keep the questions very general, realizing that we don't understand who's behind this chain.
Mr. Dyer, what type of test data would be required to ensure your finite element analysis model adequately represented the carbon fiber hull stiffness?
Typically, when we look at the finite element analysis versus hardware, we look at strain data, we'll look at accelerations if they're appropriate, and we will look at the pressure chamber data as well. So as the pressure is applied to it, are you seeing changes in that profile as it goes down, unexpected changes in there, or does it look like the pressure hull is reacting according to what you thought it was going to react to?
In your experience, is this a required engineering practice when developing a new design?
Absolutely.
And do you know if any test data was ever received from OceanGate?
The first test that I recall them doing was a scale hull test of a carbon fiber hull. It was I don't remember the scale, but it was a relatively small pressure vessel. That had strain gauges in it. That one failed prematurely. It failed before it reached the design depth on there. And I believe that data was provided to either Spencer or Boeing. I don't remember who it was that laid that hull up. Whoever laid the hull up, it was provided to them. And then the second or follow-on test, that one included accelerometers for the acoustic emissions system in there. That was data, that was about the time we were phasing out of there, and I don't recall ever seeing the data from that. I know that the data was collected, but I don't recall seeing that data.
Thank you.
Commander Williams, we've confirmed that email, Mr. Dyer, was from you to
Okay.
Mr. Nissen.
Okay, thank you.
We understand that after the design aspects of Titan were absorbed in-house by OceanGate, the University of Washington Applied Physics Lab was still utilized for pressure testing. As we understand it, there were third-scale model testing and component testing completed at University of Washington Applied Physics Lab. Is that correct?
That's my understanding. The last test that we were actively involved in was that scale model that failed. The rest of those were tests that OceanGate did on their own without us necessarily being involved in that.
Were you involved in any of the third-scale model testing?
Just the first two cylindrical models, the ones that failed prematurely. Yes, we were involved in those.
What was your experience during these tests?
The first one, the data was collected and provided to, and again, I don't remember if it was Spencer or to Boeing, but the data was provided to the group that did the analysis on that. They built a second one because of that failure. The second one had carbon fiber end domes on there because that was one of the goals that OceanGate wanted to try and see if they could achieve. That was another one that failed. And again, that data was provided to the company that did that layup, and I believe that one, I'm almost for sure that one was done by Spencer because of the dome portion of it. We didn't see the data on any of those that I can recall.
When you say it failed, can you explain what you mean by failed?
The first one collapsed. It was a catastrophic failure. The second one was also a catastrophic failure, but I believe it was the domes that failed as opposed to the cylindrical section.
Were you involved in conversations after those failures with how to make design improvements?
No.
In your experience, would you recommend constructing a full-scale hull if there was not a successful third-scale model test?
Yes, I actually would have recommended to continue with the third scale until you had a success before you did the full scale for cost purposes.
Switching subjects now to the real-time monitoring system. Were you involved in the real-time monitoring system?
We spoke to Boeing about that. They were the group that had the experience with that system. We asked Boeing if they would provide that system or put that into one of the third scale models so that we could take a look at that and see how that would benefit the program. So we were involved in getting that set up, and we worked with Boeing to get that installed into the system. I was there during that test, and I saw the data being collected on there. But again, we did not get that data. That was something that was between Boeing and OceanGate. I believe we saw the final report on that, but we were not involved in the analysis of that data.
What was your impression of the engineering department at OceanGate?
It was a tough group to work with. They had a different mindset on how to proceed with the program than we did.
Can you please expand?
Excuse me,
they-
Ms. Will-
Yes.
Could we clarify what time period we're talking about when we refer to OceanGate Engineering Team? Thank you.
Yes, I think that's important. What date are you referring to?
This is around the 2015-2016 timeframe.
Yeah. The biggest difference, the part that I struggled with the most is, in my experience, when you have a system, you evaluate it as a system and you look at fabrication and the implications of fabrication as a system. Mr. Neeson wanted to isolate those. He wanted to look at just the carbon fiber hull, just the dome, as individual components. And where we really started butting heads is when we were looking at the fabrication of the titanium dome. I wanted the foundry to see what the entire system looked like so that they could provide feedback if they saw anything that they thought was suspicious or that they wanted to put some caution to. And Tony didn't want to do that. I provided that information to the foundry, and that was when Tony really got upset, and that was shortly after that is when we were removed from the project.
Why did OceanGate and University of Washington Applied Physics Lab stop working together?
It was the engineering. We were butting heads too much on there, and OceanGate felt that it was better to terminate that and let their group take over the engineering.
What was University of Washington's Applied Physics Lab impression of the glass spheres for propulsion?
For propulsion, the glass housings.
Yes.
We like glass spheres. Those are things that are used in the industry, and they're nice and reliable. But they do have some unexpected failures that most people can't explain, typically at significant depths. We did not like the idea of using glass spheres on a manned vehicle, especially when they were going to the depth that they were trying to go to. Had it been shallow, we would have been okay with it, just because of the energy would have been somewhat constrained. But at the depths that they were going to, we didn't like the idea of those spheres out there. If they had an implosion, that's a pretty catastrophic implosion, and we didn't know what that could potentially do to the pressure vessel, to the hull.
And did you make these concerns known to OceanGate?
Yes.
And is that one of the reasons, or is that the only reason that University of Washington Applied Physics Lab and OceanGate stopped working together?
That was one of the reasons. That was probably the final reason on that. That was kind of what ended that relationship. But that was not the only reason.
Can you explain what some of those other reasons were?
It was, like I mentioned before, just the mindset and the philosophy on engineering and developing a new product. We'd had too many conflicts on how we would go about doing that.
What was your opinion of the submersible, specifically Cyclops 2, which later became Titan? What was your opinion of that submersible at the time that you, that OceanGate and Applied Physics Lab stopped working together?
With the initial concept, it was early enough in it that we felt like there was a very good chance it could be successful. The design looked like it was heading down the right path on there. Once we severed that relationship, I don't really know the direction. I would hear bits and pieces. I don't believe Stockton and I talked for quite a while after we severed on there, so I was only hearing bits and pieces of information on what was going on. But we actually felt fairly decent, like the direction. We knew that the design was not complete, and it was not ready to go full-scale fabrication by any means. But we felt like it at least had a chance of heading down the right path.
Were there specific design aspects that you recall that were not completed before you and before the University of Washington and OceanGate went your separate ways?
Yeah, the carbon fiber hull final design was not complete in my mind. We had some preliminary FEA on there. We had the third scale test that had some failures in it. So in my mind, that design was not complete. Because of those failures, they had not figured out what happened on those failures from my perspective. And I had not seen an effort to modify or to change the design based on what they saw in there. The titanium spheres, that was about the time we left is when they were shifting away from the glass dome on the forward part. They were going more towards titanium spheres. So that was very early in the design process. We had done enough work to say this is the ballpark so we can at least talk to foundries and start getting a feel for what it would cost to fabricate this and how they would go about doing that. But the design was nowhere near complete on that portion of it either.
Okay, thank you. I have no further questions.
Lieutenant Commander Whalen?
Good morning, Mr. Dyer.
Hi.
I want to discuss, or before we move away from the topic we had, as we had just discussed, the 17-inch glass spheres, or spheres which were the motor pod controllers, which were external to the pressure vessel.
Yes.
Can you explain the importance of those as for the propulsion of the Titan submersible?
Yeah, those house the motor controllers and the interface between the internal electronics in the sub and the external. So that was the interface to those motor controllers. And the motor controllers are the device. They're the electronics that control the actual thrusters themselves. So those house the motor controllers and that interface electronics.
And in providing your professional and technical opinion to OceanGate at that time, had you conducted your own technical research as to what a failure of one of those would do?
We only heard anecdotally of the industry and experiences of researchers who had used those in deep ocean work. Typically, when they failed, they lost the entire vehicle, meaning the vehicle either completely shut down or the vehicle was completely lost. Prior to that, I believe there was a HUI vehicle that had been operating fairly deep. I think it was deeper than 6,000 meters, and they lost that vehicle. And the reason for that, the potential reason for that was they believed that the glass spheres had failed and taken the vehicle out. I don't know if that was ever proven or not, but that was what was suspect at the time of that failure, and that was about the time that we were pushing back on using glass spheres for the manned vehicle.
So within that statement, you used the acronym HUI. Can you please tell me who
That's
HUI is?
Woods Hole Oceanographic Institute.
And then, sorry, thank you.
Yeah.
And then you also, by lost, can you please explain what lost means?
It's my understanding that the vehicle, they did not recover the vehicle. If they did recover the vehicle, it was probably in pieces. But my understanding is it was a non-functional vehicle at some point in time during that dive. And they believe that was because the glass spheres had failed.
Is there ever, did you uncover or discover any evidence as to the amount of pressure or that would be caused by one of the failures of the sphere at the depth of 4,000 meters?
We had a young engineer that was assisting on other programs, not the OceanGate one, but he was curious and he ran some numbers on it, and it was pretty astounding, the amount of energy that was released. I don't remember the numbers, but it was it was significant. It was as though a bomb had gone off. And again, I don't remember the exact numbers, but it was eyebrow raising.
Was it close to about a half kilogram of TNT explosion?
That sounds about right.
Thank you. How familiar are you with classification societies and the classing of submersibles and/or vessels for commercial purposes?
We were working with Stockton on the classification process when we through our process, and by the time we were no longer involved in the process, it was my understanding they were still pursuing classification at that time. He had considered several organizations, and he had talked to several organizations. I remember having the GL group. It's Gerschmidt Lloyd. Sorry, it's a German name I can't pronounce. But they were one organization that had a standard for manned submersibles. And that was a group that he brought out to talk to them about what we were doing and things like that. So yes, we were involved in him looking at certification of the manned submersible.
And at that time, were there classification rules or standards allowing carbon fiber as a pressure vessel for human occupancy?
No, it was unique to the industry. And when the GL representative came out and talked to us, they mentioned that they had a person on staff that would look at the carbon fiber hull as a system and evaluate how that would be classified. They didn't necessarily have an issue with it. They weren't concerned with it. They just knew that they would have to look at it differently than they did a steel hull.
So in your opinion, the classification society was open to innovation, but it would require time and testing?
Yes.
Were you involved in any of those? Were you involved in any of those meetings firsthand?
When the GL representative came out, I was involved in the meeting that took place over maybe an hour or two, but that was the only time that I discussed that specifically with them.
And what were some of the important points that you found within that meeting?
It was a pretty general discussion, so I don't know if there were any specifics talked about other than the fact that since it was a carbon fiber hull, they would have to look at it differently than they do a steel hull. They had regulations that were very defined in steel and titanium hulls. They didn't have anything specific for carbon fiber. So it was going to be something that they had to look at a little bit differently than they did with a normal metal hull.
Was that the only meeting that you were involved in with DNVGL?
Yes.
Did the communications continue pursuing DNVGL and the classification of the pressure vessel?
It's my understanding that they did. Stockton did start looking at having them certified just the hull and then later just the propulsion. So looking at system by system, having them certified system by system, as opposed to trying to do the entire sub in one foul swoop. But it's my understanding that they did continue to communicate on certifying the hull.
In the end, did the hull, to your knowledge, ever get certified by DNVGL or any other classification society?
I'm not aware of it.
And just to clarify for the time frame, and while we know that there were two Titan hulls, this was the first hull and then around 2016, 2017?
Yes.
Okay. You had mentioned the Cyclops 1.
Yes.
And the majority of your work was done on the Cyclops 1 to act as a act as a test bed for the applications that were going to be used on the Cyclops 2 and Titan, correct?
Yes, that's correct.
Were you involved in the process from when those applications went from Cyclops 1 to the Titan, and how did that transition go?
That transition took place, the majority of that took place after we were no longer involved in that. So I'm not real sure on how that transition went.
Okay. And did you take part in any dives aboard the Cyclops 1?
No. I supported a dive. Actually, I'm sorry, I did not. I did not support a dive.
Did other members of the faculty in the University of Washington Applied Physics Lab take part in any dives?
I don't believe so. I'm not aware of that.
Were you involved or were you made aware of any incidences that happened while on test dives for the Cyclops 1?
I'm sorry, you asked Cyclops 1.
Yes, sir.
I was involved in a dive on the Cyclops 1 that they did in Flower Gardens. I supported those dive operations, which the Cyclops 1, to be clear, was the steel-hulled version. Yes, so I was involved in one of those dives on that.
Correct.
And I did go down, I went down in Antipodes. I did not go down in Cyclops 1.
And can you tell me a little bit more about the Flower Gardens dive on the Cyclops 1?
Yeah, the intent of that dive was to reach a depth of 500 meters. The goal that Stockton had on that was to get it certified for 500 meters. So that we went out to the Flower Gardens area, got the sub prepped, put the people into it, and they did a dive. I don't remember if there was more than one dive. I remember one dive specifically. I don't remember if they did multiple dives or not, but I do remember one dive specifically.
And you use the term certified. Was certified to a classification standard?
So it was certified, it was a certification group, and I don't remember the name of the group that did that certification, but they had a representative out there to participate in the dive so he could verify that they had gone to a specific depth.
With Lieutenant Commander Williams, you discussed the titanium domes and rings.
Yes.
Can you tell me the difference between grade 5 and grade 3?
Grade 3, I don't remember the specifics of grade 3. Grade 5 is a higher strength titanium, which is it's typically 120,000 pounds per square inch yield. I don't remember what grade 3 is. Grade 3 may be in the casting realm. I don't remember that specifically.
And if you were to do a finite element analysis utilizing grade 5 as your titanium or for your domes and your rings, and actually conducted the build utilizing a grade 3 titanium dome and ring, would there be a measurable difference in your opinion?
I would have to look at the specs for grade 3. But if you design for grade 5 and you go to a different grade, you've got to make sure that the analysis encompasses the specs for that material. Since I don't recall what grade 3 is on there, I can't answer that specifically. I can just say that looking at grade 5 to grade 3, I would need to make sure that those specs were the same if I was going to assume that the analysis was valid for both.
Did you do any work in designing the launch and recovery system?
Yes.
Can you tell me about the launch and recovery system?
Yeah, we did. We worked on the first one. There was a second one that was the one that was used on the later dives. We did work on the first one. We took Stockton's concept of how he wanted it to function, and we worked to make that a reality. That design was 2 barges. They were barges that were pretty standard in the barge industry. They were made in a modular fashion so that they could be taken apart and then shipped across road or on trucking without having special permits. Those barges were I believe they were steel, a steel hull that had internal structures. They had 3 compartments that were separate from each other so that we could flood and purge the compartments independently. And then they had a system on them that allowed us to flood or purge each of those compartments independently so that it could go submerged as well as come back up to the surface.
And what did you believe to be the purpose to utilize this barge system?
The goal behind it was to open up the realm of what surface ships could be used for their operations. Typically, if you have a manned vehicle like the Cyclops vehicle, any cranes that would be on board had to be man-rated, which really limited the number of ships that you had access to. Ship time is very expensive, and it's very difficult to come by because ships are utilized almost 100%. They have to be in order to be functional. So it was really to open up the realm of what you could use, what access you had in order to support dives. This allowed them to put the vehicle on the barge at port so that you could load the vehicle without humans in it, and then tow it out to site, transport people over to it, and then launch and recover them without the use of a man-rated crane.
And did you ever witness this operation with the Cyclops one?
Yes.
And in your professional opinion, do you believe that it worked, it functioned properly?
Yes, I do.
Is this an operation that's used widely throughout the submersible industry?
I don't know that. I know that it was used, University of Hawaii had a system like that, and I believe that's where Stockton got the idea. I believe that's the only other group I know of that uses a system like that was University of Hawaii.
While you were working on the project, did you have any interaction with Lloyd's, the Classification Society, Lloyd's Register?
Just the one meeting where they came out to talk to Stockton about classifying the hull. So that was the GL group that I referred to.
So just to confirm, it was Lloyd's.
They were Gershwitz, Lloyd's. That was the group that came out to discuss that. I don't know if that's separate from Lloyd's specifically. They were known as GL at the time. I believe that's now changed to Lloyd's Registry. I don't think GL is out there any longer. But when we were talking to them, they were referred to GL or Gershwitz, Lloyd's.
We'll look into that. I just want to get that for the record.
Yes.
They're different
Yes.
classification societies.
Okay.
You discussed Boeing in a previous project that they had completed and you worked with them on.
Yes.
I don't remember the exact name, or I forgot the exact name, but it was a underwater vehicle made of carbon fiber.
Correct.
Was that a pressure vessel for human occupancy?
No. No, it was a smaller vessel. It was meant to carry a payload, and it was meant to be deployed and sit down on the seabed at pretty significant depths for a period of time, and then come back to the surface on its own.
And was it the same relative size and depth rated?
It was 6,000 meter rated, and it was much smaller significantly smaller than Cyclops.
Thank you, sir. That's all the questions I have for now.
Thank you.
Mr. Dyer, would you like to take a break or?
I'm fine. Thank you.
Okay, we'll keep going then, sir.
All
I
right.
just have a couple follow-up questions
Sure.
from your initial testimony. Can you further explain the concerns or the break you had with OceanGate regarding the domes fabrication?
When we were working on the domes, the fabrication part of that, we were working with a foundry who had a significant amount of experience in doing large titanium castings. I didn't have the experience doing large titanium castings. All of my experience with castings have been relatively small, and it's pretty straightforward. Large stuff, I think, is a little bit of a different beast. This group specifically did large titanium castings, and they had several contracts with the Navy on large titanium castings. So combined with their group that was working on it, they had probably over 150 years experience of doing these castings. I wanted to tap into their resources as much as I could because I didn't want to rely on my background alone. I just didn't have what I felt comfortable with. To do that, I wanted them to look at the entire system. So they saw the titanium dome, the interface ring, and the carbon fiber to see how all that went together and how that all made it up so that they could see the full picture. I wanted to make sure that they understood how it was being used and that whole system. In the event that they saw something in there or they had experience with something that I didn't know about or was unaware of, so that they could help us through that design process. That was not something that OceanGate Engineering wanted to do. They wanted them to look at just the dome. For some reason, they did not want them to see the carbon fiber hull or the interface ring. They wanted them to look at just the dome.
And I realize we're still talking about the prototype Titan
Yes.
hull, but would it be important to match the contraction rates between the titanium and the potential carbon fiber connection point?
Yeah, that was one of the things that when we did the conceptual stuff, that was something that we were concerned about. We wanted to make sure that the deflection between the dome and the cylindrical portion matched as close as we could. We didn't want non-uniform compression on there. So that was something that we worked on, and that was, we specifically made the dome elliptical shape, and we specifically modified or had the interface ring designed in a certain cross-section so that we could try and match those two deflections.
And so I'm now just thinking about the shape of the Titan prototype, and actually the cylindrical shape of it.
Yes.
Would it be possible to build a steel or titanium hull in the same shape?
Of the cylindrical shape yourself?
Yes, sir.
Yeah, yes, you can definitely do that. It becomes very heavy. Its displacement to buoyancy ratio becomes problematic. It's doable, but you end up having to add a substantial amount of external flotation in order to make sure that it can still float. The whole purpose behind a carbon fiber hull is you get to a point where the carbon fiber hull has enough buoyancy that you don't have to add extra flotation to it. Now you're just adding ballast to it to take it down and to trim it out. That's the benefit of a carbon fiber hull.
From a material standpoint, could you build a steel hull if you were willing to do the buoyancy provisions that could reach the Titanic, or would it have to be like titanium? Do you know?
It could be steel. I have not actually run the numbers, but based on other pressure hulls that I've done, you could definitely make it out of steel if you needed to.
And before I shift over to the NTSB, sir, I just want to make a couple clarifications for the record. Germanister Lloyd is the GL class society that merged with Detnorsky Veritas
Okay.
in 2013.
Okay.
So a GL and DNV are some acronyms that we're using today. So just for the record. At this time, I'd like to go to the NTSB.
Thank you for your time, Mr. Dyer, and that was a clarification I had as well. I have no further questions.
Okay.
Yes.
I'd like to go to OceanGate, please.
Thank you, Mr. Dyer. Just one question. You mentioned the testing of 1/3 scale models at the APL facility that you were doing with OceanGate. Did OceanGate continue to utilize APL facility for those tests after APL was no longer analyzing the data, as you said, for those?
Yeah, just for clarification, the pressure vessel is a UW-operated pressure vessel, not an APL pressure vessel. They're distinct organizations. With APL is a part of UW, but we don't have the chambers to do that. So that's run out of the School of Oceanography on campus at the University of Washington. My understanding is that they used that pressure chamber several times after we were no longer involved in the program.
Understood. Thank you.
Mr. Dyer, we've been going for a while. I'd like to take a 10-minute recess and to see if we have any final questions for you, sir.
Sounds great. Thank you.
Great. This hearing is now in recess, and we'll reconvene at 11:20.
I'm sorry? Oh, no, thank you.
The hearing is now back in session. Mr. Dyer, Lieutenant Commander Williams has a follow-up question for you.
Okay.
Mr. Dyer, you mentioned Stockton's vision. What was Mr. Rush's, or at least what was your opinion of Mr. Rush's vision for the company when APL and OceanGate first started working together? Specifically, was it related to oceanographic research, exploration, tourism?
When he first started, our impression was that he was focused on the research aspect of it, trying to make access to manned exploration more accessible for researchers because it was so expensive otherwise.
Did that change throughout the time you worked with OceanGate?
He changed in, not in his ultimate goal. His ultimate goal was still to provide that for researchers, but his goal, I guess you'd describe it as opening up so that he could help to fund the development, further development of it. So he started opening it up to tourism and ultimately to the Titanic dives because that was his way of trying to bring money into it so that they could continue development to get to that ultimate goal of supporting the research industry.
Were you aware that OceanGate was going to take paying passengers during their operations?
He had talked about that with us. I don't know if he had finalized that or if he had decided about that. I did have lunch with Stockton a few times between when we stopped working with him and when on their last mission. So I knew that they were doing paid tourism on the Titanic at that point in time. I don't remember that being something that he decided when we were still working with him or not.
And to clarify for the record, what year did OceanGate and APL stop working together on the submersible design?
I believe it's about 2017.
At that time, did you have confidence in OceanGate's engineering department's ability to complete a safe design of a carbon fiber submersible?
I would say I was more questioning than lacking confidence. It was just questioning whether or not they would be able to pull that off adequately. I don't know if you call that lack of confidence. I was really questioning whether they could do it.
Thank you. I have no further questions.
Yeah.
Mr. Fawcett?
Good morning, sir.
Hi.
Keith Fawcett.
Yes.
So you mentioned acoustic sensors on the prototype hull,
Yes.
and that would be the real-time monitoring acoustic sensors?
Yes.
Those are used to monitor the integrity of a hull or structure, is that correct?
Yeah, the idea behind acoustic emissions for carbon fiber or composite structures is to be able to detect any anomalies that are occurring when it's under load. They ultimately want to get to the point where they can identify where that event is taking place and characterize that event so that they can understand what that event means. In other words, is it just a settling of the structure, or is it a precursor to a failure? Ultimately, they want to be able to pinpoint where that event took place and the severity of that event.
So if you're using that system during a dive with a carbon fiber hull, would the real-time monitoring sensors be able to predict a catastrophic failure of the hull in time to protect the people engaged in the dive?
If the system had been properly characterized, it could predict when you were getting close to a failure of the system. In other words, if you understand what those events mean, you can start determining whether or not you need to get the hull out for NDT, or whether you feel like you've just exceeded what it's capable of doing and you need to put the hull up on the shelf for a museum piece. If it's properly characterized, you can use it for those types of situations, yes.
But while you're on a dive and you're at depth under extreme pressure, and you noticed and you had that system employed, would it predict, while you were on the dive, a catastrophic failure?
I don't think predict is the right word. I think it gives you an understanding of the integrity of the hull from dive to dive. You would make the decision before you even went down that the hull is usable for the next dive at the depth you're going, or it's not. I don't know that you necessarily want to rely on that mid-dive to say, well, we need to get out of here and get back up. I think you need to use it more of a understanding the condition and the integrity of the hull before you do a dive.
So you would use it forensically and not during a dive? If you had a system on the dive that was, say, color-coded, where the display said red, green, and yellow, would that mean anything in the course of a dive to the people conducting the dive?
The only way that I could see that meaning something is if you went from
Sorry,
green to yellow.
Mr. Dyer, just OceanGate has a
Yeah, Mr.
question.
Newbar, I believe Mr. Dyer testified earlier to kind of, I just want to establish basis for knowledge, because we're putting a lot of facts here before Mr. Dyer without establishing that he knows this.
Right. I think a good question here is, Mr. Dyer, were you aware of a color coding system on the acoustic monitoring system for warnings?
I was not aware that it had been implemented. I was aware that that was they wanted to do that, but I was not aware that it had been implemented.
Okay. So the basis of this question is, if it were implemented, what would your opinion be, sir?
Yeah, I think the only benefit in a dive would be if you've gone from green to the next level. If you see a change from that green status down to one of the other status mid-dive, I would think you would want to abort the dive. I wouldn't wait till you get to a red status. A red status, in my mind, means a failure is imminent.
Thank you, sir. Thank you.
Commander Whalen.
Thank you, Mr. Dyer. You had mentioned observing a dive that took part in the Everett Marina. There was a safety event or near-miss report for a dive that happened on April 30th of 2015. Were you part of that dive?
I don't believe I was. I think that was Pete Brodsky that was part of that dive.
Did Mr. Brodsky share any of his experiences with you?
He mentioned that the hatch was leaking when they submerged, and it was decided to continue down and let the hatch seal itself under pressure. That's really all that he mentioned on there.
Thank you. And we've been discussing the real-time monitoring system and the acoustic emissions and strain data.
Yes.
With regards to a carbon fiber hull, and speaking of acoustic emissions, what is that acoustic emission that it's measuring?
The way that those systems work is they have accelerometers that are located at known locations throughout a structure, whether it's a pressure hull or a bridge or whatever. It monitors the response of those accelerometers. So it's looking for any sign that something has shifted, failed, the load path has changed, any event that accelerometer could pick up. Ideally, that system needs to be characterized so when you get an event on accelerometer, you know what that event means. It doesn't really do you any good if you just see an event. You don't know what that means, other than we had an event at this location. But the intent of it is to look and see if you can find some event that has given you some idea of what's happening in the structure. For a composite structure, they're looking for, are you seeing delaminations occurring? Are you seeing fibers break? Anything that would start compromising the integrity of that structure.
So an event may mean that the carbon fiber structure is breaking down or the carbon fiber strands are breaking, causing an acoustic event?
It could mean that, yeah. It could mean anything in that system has made a sudden shift from what it was doing right before that event took place. So it could be a bond failure, it could be a fiber breaking, it could be a delamination occurring, or a bunch of fibers breaking. It could mean anything. That's why it's so important to characterize it before you rely on it to do much.
And were you aware of a way that OceanGate planned to utilize this acoustic emissions and strain gauge data to be able to localize and, over time, identify areas that had broken down significantly based upon the acoustic emissions?
Our understanding when Stockton was talking about it and when they started working on that system was that they would use that to help them identify when they needed to get NDD testing on there to verify if they're seeing something like fiber breakage or delaminations. I don't believe we were aware at the time that they were going to use that real time during a dive to abort it. I say that because when Stockton was talking about it, I cautioned him of saying, you've got to know what the data means, Stockton. If you think you're going to use that real time, if you don't know what that data means, it's useless to you real time. It doesn't mean anything to you. So we were under the impression that they were not planning on using it for real time, but for a predictive tool like we talked.
So, as you stated, this carbon fiber hull for pressure vessel for human occupancy, to your knowledge, hasn't been utilized in the past.
There was a carbon fiber hull that was fabricated for, I believe it was Fawcett or Fissett, was someone who was going to go to the Marianas Trench. And I believe that hull was fabricated by Spencer. I don't know the status of that. I do know that they had a failure on that. I don't know if they refabricated it or what, but there was a carbon fiber hull for human occupancy that was done by an individual, by a private citizen.
And was any of that, or was any data taken from that pressure hull to help?
When Stockton started considering Spencer, we talked to Spencer about that to try and figure out what we knew about that event and the data on that. I don't remember them having specific data on that. I think at the time there was still some questioning as to what exactly happened on that, whether it was a fabrication or whether it was an actual failure of the structure. I believe their conclusion was that there was an issue during manufacturing, and it was not because of the specific design or because of the material, but it was more of a manufacturing issue. That's my recollection of what they determined on that failure.
So with regards to the Titan, Cyclops 2 or Titan hull, to the best of your knowledge, what was the baseline data for which they were measuring the acoustic emissions and strain gauge?
I don't know. I don't know if they had any.
So you,
I don't know.
Okay. You weren't sure if there was any previous data?
When we were working with them, they didn't have any baseline data. They had used it for the first time in that scale version on there. That was the first time they'd collected data on there, so they didn't have anything to compare it to. So I don't know what transpired between that test and when they used it on the real hull.
Are you aware of what a delamination would look like in an RTM system?
It would be an accelerometer event. You'd see it show up on at least one accelerometer, probably multiple. And with those multiple, you should be able to then, after you've characterized it, you should be able to determine where that took place. That delamination might have a characteristic, I don't know, but it might be a different one than a fiber breaking. But testing should let you determine if you can tell the difference between a delamination and fiber breaking.
In your experience with carbon fiber, is there an unlimited life cycle?
My understanding is there is not an unlimited life cycle, but I don't know that for sure. That's my understanding.
Thank you, sir. That's all the questions I have, sir.
Mr. Dyer, would you feel comfortable talking about maintenance of carbon fiber?
Maintenance and
Just overall, how you should store and maintain carbon fiber hulls?
yeah, I don't think I have expertise in that.
Sir, were you aware of the control systems that were used on the Cyclops and what were projected to be used on the Titan hulls?
We worked with Pete. Pete Brodsky was the one who did the control systems on there. We worked with that on Cyclops 1, so I'm somewhat familiar with that.
Were you familiar with the game controller
Yes.
operation?
Yes.
Did you ever have any concerns or voice any concerns about that system, sir?
The only concern we had on that was the wireless portion on that. And we made sure that the controllers that were being used had the ability to plug in to be wired. We didn't want to rely on Bluetooth alone. We were fine using Bluetooth as long as they had a fallback of being able to plug it in with a wire.
Could that be accomplished on the Cyclops?
Yes. Well, as far as I know, I believe they could drive it wired. They didn't have to rely on wireless.
Sir, thank you. Just at this time, are there any further questions from the board or for Mr. Dyer? Okay. Mr. Dyer, is there anything that we haven't asked you that would be valuable to the investigation from
I
your view,
can't
sir?
think of anything offhand, no.
Mr. Dyer, thank you for your testimony.
Thank you.
You are now released as a witness from this Marine Board investigation. If we need to contact you for further information, I will contact you directly. If you have any questions about the proceedings in the future, please contact the board's recorder, Lieutenant Steele.
Okay.
Thank you again.
Yeah.
We will now recess and recess for lunch and reconvene at 1 p.m.
Thank you very much.